Hi guys. So I noticed in your module 1 that you were lacking sort of in the chapter 2 lecture videos. A video that was going over the first half, over the chemical components. And so I decided to make a video to sort of help with any of the atoms, elements, bonds, that sort of thing, and that may help you with your chemistry worksheet as well. So let's get started over that material. So the very first page of your notes looks something like this, and it talks about some basic definitions of matter. Now, matter is anything that takes up space and has mass. So, and you can ask yourself, is mass the same thing as weight? And you would say, no, mass is not the same thing as weight. Mass is the measurement of how much space something takes up. Weight is gravity's effect on mass. So it's like that example of, do you weigh the same on Earth as you do on the moon? And the answer is no, and that's because gravity on Earth is different than gravity on the moon. And the same if you were, say, on Jupiter, gravity would be different, so therefore your weight would be different. Hopefully that makes sense. Now, the three states of matter are solid, liquid, and gas. And we get a state of matter change if we change energy. So as energy increases, we'll get a state of matter change. So that means the one with the most energy would be gas. Okay. The chemical components that are important here that I really want to touch upon are these, the atoms. Now, atoms, that means, in Greek, that means uncuttable, meaning that we first thought that these were the smallest of the small, but we have since learned that we actually have subatomic particles, and we have three of those: neutrons, protons, and electrons. And these all have their affiliated charges. Now, neutrons, neutral, so they have a neutral charge designated with a 0 and a slash through it. And protons have a positive charge, and then electrons have a negative charge. The protons and the neutrons, these are both found in the nucleus of an atom. And the protons, these define the atom. So if you change the number of protons you find in the atom, then you have a completely different atom. Maybe you've seen this word before, element. These elements are made up of atoms. And then you have the periodic table. And the periodic table are these atoms in their most neutral state. And that has to do with charge, and we'll talk about that here in a minute. Let's continue on with these subatomic particles. Now, protons define the atom, and they give us this number called the atomic number. That's the number of protons. That's typically the smaller number that you will see either above or to the left of the symbol on the periodic table. And then we have neutrons. These are also found in the nucleus, the center of the atom. They have no charge. They're neutral. However, they do contribute to the stability, how stable the atom is. And if you change the number of neutrons that are found in the nucleus, we can get these things called isotopes. This is a very important term that I would suggest knowing. An isotope, it's a change in the number of neutrons. It's still the same element, but it has now a different number of neutrons, and therefore we call it an isotope. This is actually how we get nuclear energy. Okay? So maybe you've heard of radioactive decay with like carbon-14 dating, or PET scans that emit light that we can use to identify certain things in the medical field, or maybe certain bombs that were used with nuclear energy, that use nuclear energy. Now, okay, so what about electrons? Now, these are not found in the nucleus, and they actually sort of fly around the nucleus in an orbit. And orbit's sort of a bad word to use to describe this. It's really more of a cloud that they sort of fly around the nucleus in. It's not really so much a defined orbit as it is a cloud. So they carry a negative charge. And it's important to note here that if it is a neutral atom overall, then the number of protons is going to be equal to the number of electrons that you actually have. And therefore, it's going to make it a neutral atom. If it is not, then it will not be equal. Okay, so there are some important terms that I want you to know, like mass number, and this is the number of protons with the positive charge plus the number of neutrons that have a neutral charge. That gives us mass number. And then, of course, that atomic number, that's the number of protons. Okay. Maybe you'll see this word, net charge. That gives us the overall charge of the atom, like if it is neutral or if it has a charge. And that will be protons with that positive charge plus the electrons with that negative charge. They will either cancel each other out or add or subtract from each other because they have that positive and negative charge right there. So we'll talk about that more here in a little bit. Okay, so let's continue on with this page of notes and talk about bonds. So compounds are two or more of these atoms that are joined together by bonds. In biology, we have these two types of bonds, two main types of bonds. They're either ionic or they're covalent. So covalent are also referred to as molecular bonds, and they're only formed by nonmetals. Covalent bonds are formed only by nonmetals. Ionic bonds can be from metal or nonmetal. Ionic bonds transfer electrons, and they form a very weak bond because they're just transferring that electron. And they use this principle that opposites attract, that positive and that negative charge, like magnets, are going to attract. And we form ions. We have two flavors, either cations that have a positive charge or anions that have a negative charge. So the way I remember this is cats have paws, so they have a positive charge, and cations are a loss of electrons because they have a negative charge, or a loss of electrons, where anions are a gain of electrons because they have that negative charge. Electrons have a negative charge. A good example of an equation that forms an ionic bond is using sodium with that positive charge, so that would be considered a cation, plus a chloride ion that has a negative charge, so that would be an anion, and they form sodium chloride. So the bond between those two atoms right there would be an ionic bond. It is a transfer of electrons. Okay? So that is a weak bond. The other is covalent, and it comes in two different flavors. But this is a sharing of electrons, therefore forming a much stronger, a very strong bond. So let's look on the other side here. Covalent. Sharing of electrons, very strong. And it is either polar covalent or non-polar. The non-polar covalent bonds are the ones that form in your cell membranes, and they are very hydrophobic. So repelling water. It's what helps keep your cell membranes water free or keep water out. And then we have polar covalent bonds. And these are very strong bonds that will allow for another very important bond called a hydrogen bond. Now, this hydrogen bond is a weak bond. And it's important to note that you cannot form hydrogen bonds until you first have a polar covalent bond. So make sure that you write that down. You cannot have a hydrogen bond unless you first have a polar covalent bond. It is this property that explains, or it is these type of bonds that explains a lot of the properties, the weird properties of water. So, because of the nature of these polar covalent bonds that allow for hydrogen bonds to happen, we get these really weird properties of water. A polar covalent bond, again, is the sharing of electrons, but it is an unequal sharing of electrons. In water, oxygen is heavily negative, has a heavily negative charge. And in water, you have two hydrogen molecules, and they have a positive charge. And there is this term, electronegativity. And oxygen is greedy whenever it comes to sharing the electrons. And so it's heavily pulling all of the electron power, if you will, to the oxygen side. And that's what makes water a polar molecule. Now, when we have two oxygen or two water molecules together or side by side, each having their own polar, between the two water molecules, we can actually form a hydrogen bond. Remember, the oxygens have a heavily negative side, and the hydrogens have a positive side. The hydrogen bond forms between the hydrogen of one water molecule and the negative charge of the oxygen of the other water molecule. That bond right there is a hydrogen bond. Okay? And they help keep water molecules together. It is much weaker than a covalent bond. They only form between the parts of the hydrogen bond and that oxygen. This attractive force leads to surface tension, sort of what allows bugs to walk on the surface of water. It allows for something called capillary action, So, for example, whenever you have a paper towel next to a puddle, you move it closer, and some of that water will be pulled up the actual towel. That's capillary action, and it is because of these weird properties of water from those hydrogen bonds. Those are just a few of the examples. Okay. So that was surface tension, the constant forming and breaking of the hydrogen bonds, and then capillary action. So continuing on talking about water as an important component of biology, it is also an important polar solvent. It dissolves and dissociates or breaks apart ionic substances. So like when we talked about sodium chloride, if you put that in water, it will break apart into its components of sodium and then just chloride. Salts are these ionic substances or compounds that dissociate or break apart into these separate ions in water. So when you add them to water, we get either cations, remember that word, or anions. Which one has which charge? Hopefully you said cations have a positive charge and anions have a negative charge. And then from there we get electrolytes. Sodium, that has a positive charge, so that would be a cation. Potassium has a positive charge, that's also a cation. This is calcium, has a 2+. Iron also has a 2+. These are both cations. And we're going to talk about what these actually mean. Electrolytes, what this word means is that it can actually conduct electricity in solution. Your body will use ions like this that have a charge to move electricity. And really what electricity is just the movement of charges. So if it has a positive 2, like iron does, what does that mean? It's a cation. And what do we say the definition of a cation is? It a loss or a gain of electrons? Hopefully you said it's a loss of electrons. So if it is a 2+, it's a loss of 2 electrons. What if it was like this? What if we were talking about chloride and it's just a negative? There is an understood 1 there. So that would be an anion, and an anion, is a gain of electrons. So that would be a gain of 1 electron. Let's talk quickly about, before I let you go, let's talk quickly about your chemistry worksheet. Let me add a page to this. In your chemistry worksheet, you have to fill out that chart. That first chart is asking you about the atomic number. And that comes from the periodic table here. That is this number right here. Get a color maybe that you can actually see. That's this number right here, or this number right here. That tells you the atomic number, which is also the number of protons. Right? And then from there, if I pull up, let me pull up one of these real quick. And then it asks you for the atomic mass. And the atomic mass is an average of all the isotopes. an average of all the isotopes. And on the periodic table, I don't think that mine has it on there. No, it's just the atomic number decimal. The atomic mass is going to be the decimal under the symbol, usually on the periodic table. Okay, it's a decimal number under the periodic table. So for instance, if this is hydrogen, this is the box for hydrogen. Typically, the atomic number will be right there or right above the number, and then you'll have a decimal number underneath the symbol, and I think it's like 1.001. That would be the atomic mass for hydrogen. Then the next one it asks for you, or ask of you, is the mass number. And if you remember, this is one of the definitions I asked you to know. Mass number. Mass number is the number of protons, which have that positive charge, plus the number of neutrons that have a neutral charge. And you can actually get this number, which is going to be a whole number, by rounding the atomic mass. So for hydrogen, the number right next to the decimal is a 0, so you would round down, and the atomic mass for hydrogen would be 1. If it was 5 or above the number right next to the decimal, then you would round up, and then the mass number for hydrogen would be 2. So hopefully that made sense to you. Okay. Then from there you can figure out the number of protons, electrons, and neutrons. You can find the number of electrons using net charge. Remember, if it is a neutral atom, meaning there is no charge right here, and all the ones from the periodic table, straight from the periodic table, are neutral, then the number of protons will equal the number of electrons. If it was written like this, hydrogen plus, that is a cation with a positive charge. And remember what cations are. Is it a gain or is it a loss of electrons? Okay. If this is the atomic number for hydrogen, that means it has 1 proton. And if it is neutral, with a neutral charge, so the symbol would just be like this, with no charge right here, then it would have 1 proton, and then it would have 1 electron, because it would be balanced out if it is a neutral atom. It would not be the same, though, if it had a positive charge right there and was a cation. So you must know what cation means. Is it a loss of electrons or is it a gain of electrons? Okay, so hopefully that helped you with that first page of the chemistry worksheet. Also, I will mention that whenever you're doing the shells on the, what page is it? Let me see. On the next page, page 2, I'll ask that you write the electrons in this form. So you have the center circle where you write the number of protons and the number of neutrons. And then on the shells where you write the number of electrons, write them like this. And you only have to go out to the 3rd shell if you need that at all. So remember, this is the octet rule. You start by filling out the 1st shell and then the 2nd shell and then the 3rd shell. So for instance, if you know you have 5 electrons, if there are 5 electrons, you would fill out the 1st shell with 2, and then there would only be how many left? 3. So that means you would only have 3 in this 2nd shell, and that would be your valence electron. And remember, a valence electron is the number of electrons in the outermost shell of the atom. You can check this by looking at the periodic table and looking at the column that the element is actually in. So here in this first column, you will have 1 valence electron in the outer shell, 2 for the second one, and then it skips over here to 3, 4, 5, 6, 7, and 8. And that works for all of them except for helium, and that is because, if you notice, its atomic number is 2. So if you only have 2 protons, it means you're only going to have, if it's neutral, then you only have 2 electrons. So obviously you're only going to go out to the first shell, so you're not going to have 8 electrons. But for the rest of them, it works, because these are your noble gases in that last column right here. But you can check your number of valence electrons by looking at the periodic table. Anyways, I hope that helped. Just let me know if you have any more questions. And then I guess that's it. Happy studying.